Today we'll be solving the following differential equation. It is x times dy dx minus y equals 2x squared y, where we have an initial condition of y evaluated at 1 equals 1. And just to start off, we could add y on both sides. So we have x dy dx equals 2x squared times y plus y. And from here, we can multiply dx on both sides. So we're going to have a x dy divided by dx times dx equals 2x squared y plus y times dx. You can think of the dx as canceling each other. We have x dy equals 2x squared times y plus y dx. And from here, you can notice that we could factor out a y. We have x dy is y times 2x squared plus 1 dx. Now we could rearrange the terms to have dy over y equals 2x squared plus 1 divided by x dx. So from here, we could just integrate. The integral of 1 over y dy is the natural log of y. And this integral, we have to do some more work. We could think of it as the integral of 2x squared divided by x plus 1 over x dx by separating that monomial. So we have the natural log of y is the integral of 2x plus 1 over x dx. And these are pretty standard integrals. So we have the natural log of the absolute value of y is 2x squared divided by 2 plus the natural log of x plus c. We could see that the 2's divide to 1. And we have the natural log of the absolute value of y is x squared plus the natural log of the absolute value of x plus c. From here, we could exponentiate both sides. So the natural log and e will cancel. With the absolute value of y is e raised to the x squared plus the natural log of the absolute value of x plus c. We have the absolute value of y equals, using exponentiation rules, we have e to the x squared times e raised to the natural log of the absolute value of x times e to the c. And to solve for y, we have to add a plus or minus. So y is plus or minus e to the c times e to the raised to the x squared power times e raised to the natural log of the absolute value of x. And we could let plus or minus e to the c equal to c, some constant. So we have y equals c e raised to the x squared times e raised to the natural log of x. And now we could simplify this into c raised to e to the x squared, and e raised to the natural log of x is just x. So we solved for y, but we said our initial condition was y evaluated at 1 is equal to 1. So we can rewrite this as y of x is c x e raised to the x squared power. But our goal is y of 1. So if we just plug in x equals 1, we have c times 1 e to the 1 squared. But that's just c times e. So we have y evaluated at 1 is c times e. But we said y evaluated at 1 was exactly 1. So we have 1 equals c times e. And solving for c, we have c equals 1 over e. So now we could say that y is 1 over e, which is this c, e to the x squared power times x, and this is the solution to the differential equation satisfying y evaluated at 1 equals 1. Thank you very much for watching.